Now, a common question I get is, help me to understand how much space I'm consuming in my snapshot pool. Now, there are two commands we can use to learn this. The first is report snap pool, and the second is report images with the -s option. So, report snap pool is going to give us a full view of where the space went in the snapshot pool by app and by category. Now, in this example, you can see there's only one app being listed. It's an Oracle an Oracle app. And here are the numbers that matter. The first number here is the app size. So this is the size of the actual customer data on the source side, as reported by the app. So Oracle said, I am a 2,566.9 GB database. That's Oracle telling us. So this is an important number because this is roughly how much space is being consumed in disk on the source side. So we make a golden copy of it, and this is known in our terminology as the staging disk. Now, the staging disk in this example is consuming 874.9 GB. Now, this is interesting. Why is that a third of that? Roughly a third. And the answer is compression, because on the Actifio Sky or VDP appliance, we compress the data. So we've got a saving here already. Now, we've got two other numbers here that matter. This first is the snap, and the second is the mount. So snap is snapshots of the staging disk. In other words, this is data that we need to use to maintain point-in-time copies of this disk. And mount is effectively new data created by the users of mounts of these snapshots. So these three columns, or in fact, you can see we've got a few columns here, but these three, stage, snap, and mount, are the ones that most interest us. They should add up, maybe slightly off with a little rounding, to the right number. Now you can actually see if I just drag this up right down the bottom. Oops, sorry, try that again. Down the bottom you can see 1844 is the sum of those three columns. Sure enough, here's 1844.6. Yeah, we're off by 0.1, but that's fine. So what this is telling us is that this app is consuming 1844.6 GB on disk, but remember the app size is 2566, so we've already got a saving here. Now, I'm going to show you the output of report images, and I want to make one point, which is that if you're capturing the output of these two commands, capture them at as close to the same time as possible. The reason for that is it makes it easy to validate the numbers. In this example, it's actually a bad example to share with you because I haven't done that. I've actually captured them at different times. And you'll see this in a moment. So remember that number 1844? If I go to report images, what this actually shows is the amount of space consumed by each image. And we've now divided into three separate columns. Now, if I just sum all of these columns, all of this here, you can see these three columns actually adds up to 1878. That's not the same as 1844. Now, if you had collected the output of these two commands at almost exactly the same time and there was that big a delta, we probably have an issue. But in this case, it's caused purely by the fact we didn't collect them on the same day. They're actually collected 2 days apart. But here's a good hint that we are close. 874.9 is the stage. If I go back to report images, 874.9 is the stage. So that shows that the variation is in snapshot, which makes sense. New snapshots have come in, consuming more data. Now, let's talk about space consumption per image, because this is what this is showing us. Report images shows us images, and I can see that there are 28 images, there's 29 rows plus the header row, 28 images of this application, a mix of snapshots and mounts of the snapshot. And you can see nearly every snapshot has at least one mount. They're all sharing the same stage used. This is because we have one common golden copy and we need to report the usage of it somewhere. Now, people would go, well, why not you just have this 874 against every image? But of course, all of these snapshots are using the same shared common staging disk. So we only need to report this size once. If I reported it more than once, you'd sum it up and then go, hey, these numbers don't match. So then the question is, where do I show it? Do we show it on the oldest image or the newest image? Now, there was a temptation to show it on the newest image. However, it's a really important point. This staging disk will persist as long as every snapshot persists. So we show it against the oldest image because we could start going from new back to old and it would persist until every image is gone. So, we just had to make a decision, show it at the bottom, show it at the top. Well, it doesn't really matter. Either way, we know that All of these images are sharing the same staging disk. Now, it is possible, by the way, for an app to have multiple staging disks. Usually if what this thing here called the vert size changes on smaller apps. But in this case, you can see there's 0 in every column, so we know these are all using the same shared common golden copy. This is good. This shared snapshot used is a Sky feature. It is not present on CDS. It would also be present in CDX, by the way. So this column appears, or doesn't appear in CDS, appears everywhere else. Now, these are blocks that are shared by more than one snapshot. This is a bit of a quirk of the way we do snapshot accounting. What it means is that this space could not be freed by expiring one single snapshot. You'd have to expire at least 2. And unfortunately, we're not going to tell you, or we can't tell you, which 2 snapshots. The bottom line here is that number there, 439. If you expire at least 2 snapshots, you get some of it back. But it's pointless even thinking about it because we don't know which snapshots to expire. So we're going to ignore that number and just focus on column K, snapshot used. Now, there's a couple of interesting rules here. The first is, in general, the older the snapshot, the more data the snapshot keeps. And since we're sorting these from oldest to newest, you can see this on the consistency date, 5th of June, all the way through to the 7th of August, you can see that rule is reasonably, not 100% true, but reasonably true. The older the snapshot, the more data the snapshot has. When we are expiring snapshots, we should expire from oldest to newest. So this is also good because if we're trying to reclaim space and you start expiring the oldest snapshots first, you're actually going to get the most bang for buck by doing so. However, if I decided that this snapshot, you can see there's 134 GB that will be recovered if I expire this snapshot. Can I do it right now? And the answer is no, because this snapshot has a mount. How do I know this mount lives off this snapshot? Because their consistency dates are the same. There is actually another hint down here in the disk names, which is that the snapshot disks of that image are the parent disks of this image. But that gets a little bit convoluted. It's much easier to just focus on the consistency date. If 2 images have the same consistency date, they're both from the same point in time. One of them is a mount. That means that this image is a child of this image. The mount is a child of the snapshot. I cannot expire the snapshot unless I expire the mount. So what's interesting though, if I expire this mount, I'll get 6.6 gig back. And when I do, this image will automatically expire. Why? Because I'm recording this on the 8th of August. This image should have expired on the 5th of June, but it didn't because it has a mount. So if we unmount and delete this mount, this image here, then we'll get 6 gig back, and at the completion of the unmount and delete, we'll get 134 gig back. The same image down the bottom here, or the next image down, is kind of the same. You can see there's a snapshot, 16th of the 6th of 19, should have expired on the 16th of the 6th of 19, should have expired 2 months ago. The moment we unmount and delete this mount, we'll get 34 GB back, and then this guy will automatically expire. We'll get 80 GB back. So you can see it's relatively easy to see how this is playing out. Next one down, exactly the same. The mount's using 37 GB, the snapshot's using 55 GB. And it's interesting too, if you look, that guy's a snap, that guy's a snap, that guy's a snap. Notice that rule. The older the snapshot in general, not 100%, but in general, the more data, which means that the older snapshots are the ones we should always focus on. And we should always expire from oldest to newest anyway. Now, the other thing to think about here, which is interesting, is remember the size of the app size, 2566. So that's the size of the data. Now, look how many mounts we've got. There's one, there's another, there's another, there's another. There's actually 13 mounts here. So let's just do a little sum. If I go equals 13 times that number, that's 33,000 gigabytes. Now, do you remember how much space we consumed? If I sum all of those columns up, 1878. So I'm going to pop that in there, 1878. And then here, I'm going to go equals that, divided by that, and I'll times it by 100 to get a nice easy percentage. 5.66%. Now, if I just go equals 100 minus that, it's a 94% saving. So in other words, if I had 13 separate full copies on disk, they would consume 33,000 GB. But instead, including the golden copy, I'm only consuming 1878, which means that the before picture, 13 full copies, the after picture, 13 virtual copies, I'm saving 94% of my disk space. That's huge. And it's a great example of how I can demonstrate where the space went and demonstrate the benefits of using virtual copies.